First, you must open the Microsoft Excel software. Then import your Mach 1 raw data acquired through the moveRelative function in a worksheet. To sort the time vector from the raw data faster, it is possible to create a function that will recognize the even integers between 0 and 100. In Excel, this can be done by writing an empty column as shown, where A2 is the cell holding the first element in the time vector. Drag the fill handle across all rows with time points to copy the formula to calculate true and false values for each time point. Note, simply double-click the fill handle to accomplish this task more rapidly. Select the entire sheet, then select Data, and then Filter. Sort the new column containing true and false values to display only the true values or the even integers between 0 and 100. Click Select All, then copy and paste into a new worksheet. Then import your GUM correlate data in the new worksheet. Using their common time vector, assign each set of shear deformation value, which is the upper layer and lower layer, to its corresponding force value, which is Fx. Compute the applied shear stress for your sample, referring to the reported length and width in Table 1 using Equation 1, where Fx is the force applied on the sample in newtons as read on the x-axis, and A is the area of the sample in contact with the flat indenter in millimeters squared. This gives units of megapascals for the shear stress. Compute the shear strain for each layer by multiplying your set of shear deformation or epsilon value by a factor of 2 using Equation 2. The shear modulus is defined as the ratio of the shear stress over the shear strain. Plot the shear stress strain diagram for each layer and extract the slope at its linear portion to get the shear modulus. Report the shear modulus of each layer in Table 1. Repeat all steps for the second sample, in this case the hybrid hydrogel.